Let me just get a little closer. All right. Hello, everybody. And I'm glad you're here for our live stream. I'm here with my 21-year-old son, Kobe.
Hello.
And did you want me to just start with anything?
Yeah.
Okay, great. I like that. Okay, we're going to start. I took plenty of notes, as you can see here. And most of my notes came from the What If YouTube channel. A shout out to them. And also a shout out to what other channel I got. I'm late because I was watching his channel about Kobe's great idea about Greenwich, time. And let's see. And that YouTuber's name is, I'll get to the first page of the notes here. Oh, his name is Johnny Harris. And shout out to Johnny Harris. He lives in Washington, D.C. Thanks to his channel, I'm learning even more. So we're going to start with, and Saturday, April 22nd was Earth Day. But we're going to say, and from the, of course, the What If channel, YouTube channel, we're going to start with what if you got stuck in a time loop? So, Kobe, have you ever heard of a time loop?
Yeah.
Oh, good. Okay. And for those who don't know what a time loop is, it started with, Albert Einstein discovered it. There's this theory of general relativity. You will find out that a lot of this stuff is connected to Albert Einstein. And we start with space-time. And space-time is the 3 dimensions of space and the 1 dimension of time, and they're all joined together in a continuum. And what is a continuum? Do you know what that is?
Well, you tell us.
Oh, okay. All right. A continuum is a range or series of things that are slightly different from each other and that exist between 2 different possibilities.
Okay.
Yeah, for me, that's interesting. And we have space-time continuum. And space-time continuum is the 4-dimensional continuum having 3 spatial coordinates and 1 time coordinate that together completely specify the location or particle or event. And that all leads to this wonderful thing we know as gravity. Okay? And we'll talk about gravity, and then I'll get Kobe talking here. All right? Okay, gravity, yeah, this is what bends the space-time continuum. And that's why they say, according to physics, time travel is possible. You can believe even if it's not possible, it's still fascinating to me, even if it's not real. And gravity is a force that attracts a body towards the center of the earth or towards any other physical body having mass. Okay, so what is your views on space-time and time travel? Do you believe it or do you not believe it? And if so, why or why not?
Well, I would say that if time travel was possible, then Stephen Hawking would be able to have that buffet that he had.
That's true. And also, he did have a time traveler party, and supposedly no one was able to come for whatever reason.
Correct.
Oh, yes. Okay, so we'll continue now. Oh, and to make this time travel possible, one needs a big enough access to a black hole or a time machine. And a black hole is a place in space where gravity pulls so much that even light can't escape. Formed when the center of a very massive star collapses in upon itself. So I find black holes quite fascinating and interesting as well. Oh, but would I want to go on one? No. And with this, my opinion of time travel is, I would like the time travelers to come to me. I don't want to go to them because I don't want anything the bad to happen to me or my, future, descendants. Okay. And then we have another way to get through time. Have you ever heard of a tripler cylinder?
No.
No, you haven't?
No.
Oh, okay. It's called Tipler, excuse me, Tipler, Tipler. I haven't heard of it either until a few days ago. And that you can go back to where time began, but it has to be an infinite length. It's like a tube, think of like a giant pipe. And then space-time, it folds upon itself with this Tipler cylinder. And I'll give you more details about this Tipler cylinder. It's a massive and long cylinder spinning around its longitudinal axis. And rotation creates a frame dragging effort. And let's get my pen here. I was correcting myself. And fields of closed time-like curves, transversable in a way to achieve subliminal time travel to the past. And the length has, like I said once before, infinite, but you cannot travel to the future and you can't have any negative energy. Just think of protons, neutrons, electrons, instead of them being positive, they're negative in the atom. So in other words, here's one possible scenario. You can travel back to yesterday and start your day all over again. Then you'll be in control of when to go back to the future. Now, how would you feel about doing that, Kobe?
Sounds a bit like Groundhog Day.
It is. And that movie was discussed. And the creative Groundhog Day did discuss that with the What If staff. Yeah, it does. Would you want to go through anything like that? Why not?
Don't want, because that sounds pretty miserable.
It does. Oh, so you excuse Kobe, he just woke up.
Mm-hmm.
Yes. What about it would be miserable?
Going back to the same point over and over again, right?
Yes, that would get boring. If you had a good day, you get tired of that good day. Too much of a good thing. And if you had a bad day, it'd be a nightmare.
Right.
Yes. And if you die during one of these travels, you wouldn't wake up in your bed the morning before. That would really end it for you. It'd be a really true death.
Oh. So slightly different.
Yes. In the past would not be changed. And there'd be no paradoxes. Now, paradox, as you can see, I really did my homework. It's future events are the cause of past events, which are the cause of future events. And you don't know which came first, the chicken or the egg, kind of thing, like round and round and round, like a vicious cycle. And then we have predestination paradoxes. This is that prevents the time paradoxes. I'm sure glad I came prepared for this live stream. But in Kobe's defense, I did not make him prepare because I can just ask him open-ended questions and he'll do a good job of answering them. And this is and why am I having him not read my notes? Because it's my organized mess. No one would understand but me anyway. And the predestination paradoxes are when you travel to the past, you're always been part of that past. Your presence would not change a thing. So if you go back to like when you were 10 years old, I guess you see yourself as a 10-year-old, but you will not change what happens during that time. And I would not want that. I guess seeing me once at the age is enough. Okay, and closed time-like curves aren't actually closed at all. And then we have another what if. What if an alternate timeline would appear every time you travel to the past? Wow. Imagine that. What's your thoughts on that, Kobe?
I feel like an alternate history user would love it.
Yeah, I think they would. Why would they love it?
Because it would make them lots of ad revenue.
Oh, I bet. Or continue living in an alternate universe, unable to return to your original universe. unless you open a portal to a parallel world. So the physicists came with this thing called a time loop, which equals a causal loop. And what is a causal loop? It is a theoretical proposition by means of retrocausality or time travel. And retrocausality is effects happen before causes. So instead of cause, then effect, it's an effect, then cause. It's kind of like backwards. It's almost like starting the end of your day, and then you end up at the end of the beginning of your day, like almost like walking backwards. That's how I see it. How do you see it?
The same as you, actually.
Okay, that's very interesting. And I'm glad we see it the same way. All right, and now here's another what if. I just love this what if channel. Love you guys, if you ever see this. All right, what if time is an illusion? Is time an illusion? Why or why not, Kobe?
That sounds like existentialist clickbait.
It is, but do your best to answer anyway.
Well, what would make time an illusion?
That's a good question. I guess if there was nothing to prove that time exists, then it would be an illusion. Now your dad, Randy Kimmick, the way he explained it to me was that, like when you're living, time is real, but in the afterlife, time is not. If I understood him correctly. If I did, I apologize to him. All right, we're going to back to Albert Einstein in that magical year 2000. I guess I meant to say 1915, and I notes I put 2015. But so, yeah, being the perfectionist that I am, I'm just going to write 1915. All right, and then the theory of relative motion. Once again, Albert Einstein discovered that as well. So the theory of relative motion are the laws of physics, in which this is how he explains it. The laws of physics are the same for all non-accelerating observers. Okay, so what are your thoughts on that?
Sure.
Okay, can you elaborate, even if you don't?
No, because that sounds just like a bunch of physicist nonsense.
It most likely is.
Well, because I mean, there's physicists who say that the universe isn't real, but you have to be very technical about what reality means.
That's true. See, you're elaborating. I appreciate that.
And I just don't like that. It's like, no.
That's why when you were younger, you preferred chemistry anyway.
Mm-hmm.
Do you still like chemistry?
It's okay.
Okay.
I use it for making narcotics.
No, you don't.
Well, hey, gotta pay the bill somehow.
No, he's kidding. Don't get my YouTube channel canceled. Okay.
Well, you're not gonna get canceled.
Oh, trust me. Facebook is already after me already. Okay. Don't need YouTube on me too. All right. So I'll continue. If you were to watch a car drive past you, you would interpret the car's passengers as moving at the same speed as the car. Actually, we do. It seems like they are moving as fast as the car when we watch them. Okay, since their speed is relative to your position as an observer on still ground. So I guess as fast as they're going is how fast we think they're going in the car. And inside the car, the passengers feel like stationary objects. So that's true. When we ride in the car, it feels like unless you get car sick, it feels like we're not moving sometimes.
Well, what about if you're driving super fast and there's a ton of G-force applied to you?
I guess we'll get to that soon. And that's a good question. Since their motion matches the car's motion relative to the outside world. And then also the perception of how time passes can be different between two observers. And one exception to relativity is light. I'll say that again. One exception to relativity is light, because light always moves at a constant speed. And space-time is a link between time and space. So you have time over here, space over here. In the middle is space time.
Oh, really?
Yes.
Could it be the other way around?
Well, okay, let's put that. You have one, this side could be space, this time side could be time, but if it's time space always stays in the middle.
Well, but can we move it to the end?
The space time?
Mm-hmm. Like an addition problem.
Oh, and maybe we can. That's a good point. I never thought of it that way, but we might be able to. The What If channel did not, elaborate on that. Okay, and it's depending on how much faster one is moving compared to the other. Yes, so, that's another thought. Excuse me, I look for another pen. Let's get my pen over here. All right, I'll look for it later. All right, so we're going to move on. And also, another thing, it is possible for two observers to have two accurate perspectives of time's passing. But for those perspectives to be different, whose clock is right and whose clock is wrong? What do you think? Whose clock?
If it's not my clock, then they're wrong. This is just to boost my ego.
Oh, okay. So you feel like if you think you're right, you are right.
Yes.
Okay. Both clocks are actually correct because different time zones do exist.
Oh, really?
Yep, we do.
I
They do,
thought-
but they didn't always. We'll get to that.
Well,
At the end.
I thought Japan had the same time zone as Ecuador.
Yeah. When we get talk about Greenwich Mean Time, we'll elaborate on that. So different time zones exist. Your watch and someone else's watch will read different times every second of the day. And so we think the passage of time is objective, which is universal. So time can be objective, whatever you think it is.
Well, there's atomic clocks.
That's true. Before atomic clocks, I guess it was more objective.
More subjective.
More subjective. You're right. So opinions. We agreed on the same system of time to organize our busy lives and be on the same page as our neighbors too. And so, be accurate for keeping track of the past, present, and future. So that's what time is good for. And also, there's a star called, and then there's the true nature of time is trickier to grasp because the past, present, and future could all exist at once. So imagine the past, and the present, and the future all in one place.
So it's like past self pulls out a mortgage you can't afford.
Right.
And then present self regrets it, and future self forecloses on that mortgage.
Yeah, that's genius. Oh my God, that's genius.
And then future self jumps out of a window and dies.
Oh, okay. And then there's a star called the Proxima Centauri, which is a star that was discovered by Robert Innes in 1915. It's 4 light years away. It's the nearest known star to the sun, our sun. And light from the sun is 4 years old. So any sun we get is 4 years old. It takes 4 years from the sunlight to come to here, to us.
And people say dial-up is slow.
Yes. So it's the nearest star of Centaurus, which is Latin. But if the star exploded, we wouldn't know about it till 4 years later, because it's 4 light years away. And it's a small, low-mass star located 4.2465 light years away, which is 1.3020 PC. PC is a parsec, which measures large distances to astronomical objects outside the solar system. So it's 4.2465 or 4.2465 light years, or 1.3020 PC away from the sun in the southern constellation of Centaurus. So the parsec, the PC, measures large distances to astronomical objects outside the solar system. And In other words, this is how they do the math. I'm not good at math, so I let them do the math for me. All right, so 3.26 light years is equal to, or 2,265,000 astronomical units, which is AU. And 3.26 light years is based on apparent stellar motion as observed from Earth. Example, 30.9 trillion with a TR kilometers is 19.2 trillion, TR miles.
Well, what about in the length of gumballs?
Oh my God, I can't imagine that going forever.
Well, but that's the only unit of measurement I'll acknowledge.
Okay, that's a good unit of measure, very motivating. Yeah, now you can see all Kobe. All right, the speed of light is constant. So in other words, 186,282 miles per second, which is 299 million 792,458 meters per second. That's a lot. And the faster you move, the slower time does. So moving near the speed of light, you age more slowly.
Oh, question.
Yes.
How large is an astronomical unit?
How large is the astronaut? I have to go back to my notes to see.
Is it like the distance between the Earth and the Sun or something like that?
It could be.
Well, you don't want to have notes.
Yes, but they didn't mention that part of it.
Well, yeah, I feel like that's a pretty relevant thing to know.
But someone else who's listening to this live stream can tell us. We don't have to know everything. Okay, and that's moving near the speed of light where you age more slowly. That's called time dilation. And so that's for example, say an astronaut's on a planet that's 4 light years away. His or her present is unfolding 4 years ahead of us. So their present is, so we're in 2023, so they're already in 2027. Anything occurring on Earth is already 4 years in his or her past. So like as in the past, present, and future exist all at once.
Well, can they go backwards?
Can they go backwards? I think it's possible for them to go backwards.
Oh, okay, so for that planet,
Like a wormhole, which we'll be covering soon.
So if it goes somewhere, it goes backwards. They'll talk about how, like, I don't know, like Beakman was the best show ever.
It could be, yes. Yeah. And then the speed of human motion approaches the speed of light. That's the relativistic Doppler effect, Doppler. That's the change in frequency and wavelength of light caused by the relative motion of the source and the observer. And now we have, past, present, future. That's the moving spotlight theory. Okay, there is only one absolute present. Changes moment by moment as if a spotlight is moving on it. Wow, so the spotlight could be on me and then go on you. So that's an analogy of how the present can change all the time.
Is there a past participle?
It could be, yes, because sometimes when things happen in the past, they're still happening in the present. And going to happen in the future.
Well, it sounds like something used for grammar, not space-time continuum.
That's true. I am a liberal studies major, so I add a liberal studies to it, even though I don't do math. All right.
Well, then what's 2 + 2?
4.
Wait, but I thought you were bad at math.
Well, I'm glad I'm good enough at math to function in society. Just put it that way.
Well, then what's 15 times 3?
45.
Okay, good.
Okay. I'm glad I don't embarrass you or myself. Okay, continuing. No objective past, present, or future. Okay, the illusion of time is crafted by our memories, experiences, and upcoming plans, which help us organize our life into a neat sequence of events. And the sequence of events is variable It depends on the speed. If you move fast enough, you will get there in no time. That's how you can think about it. I guess literally and figuratively. And now we're on wormholes, which we mentioned before. Other words, from the What If channel. What if a wormhole formed in our solar system? Okay, we're going to 1935, and that's where physicists Albert Einstein and Nathan Rosen, discovered bridges, which is space-time, and they called it the Einstein-Rosen bridge, and that's known as a, wait for it, wormhole. And a wormhole is a shortcut through space-time, 3 dimensions of space, 4th dimension of time. In other words, space plus time equals space-time. So what are your thoughts about wormholes?
If I go for it, will I die?
You can if it collapses on you, which we'll be getting to real soon.
Well, then that sounds kind of scary.
It's very scary. Okay, it's less like a bridge, but it's more like a tunnel, a wormhole. It links 2 different points in space-time. Yes. So you can end up in a different galaxy or universe in the past, but must keep the wormhole from collapsing. And no one's ever seen this wormhole.
Well, that's why it's theoretical physics, not physics.
Right. It will not be discovered anytime soon, and it's microscopic for the moment. It's what to make it wide enough for a human. Then you have a crazy amount of mass, which is the amount of matter present in any object or body. And the matter is a solid, liquid, gas, or plasma. Think of plasma, like silly putty. Or anything, gooey. And then the smallest black hole is the size of an atom. Okay? So, in other words, but it has the mass of a mountain. You can imagine how heavy that is. And the black hole is just the remnants of a large star that dies in a supernova explosion. And what is a supernova? A powerful and glowing explosion of a star. And what is an atom? A particle of matter that uniquely defines a chemical element. And what is an element? It can't be easily broken into smaller pieces.
Are you positive about electrons?
Positive about electrons? Yes, I am. I really am.
This theoretical physics sounds a lot like a role play.
Yeah, it can be. Oh, yeah, I'm just drinking some tea here.
And you know what else is theoretical?
What would that be?
Your degree.
Oh, my liberal studies degree. Well, that's all right. It's not about my degree. Okay, gravitational pull. That redirect the tilt and rotation of all the planets in our solar system. Things would go back to normal soon enough. And it could be unstable, the wormhole, and collapses quickly because the walls attract each other. And why do they do that? And I guess it's because it needs exotic matter. The exotic matter are physical properties to keep the wormholes open. And exotic it violates no known laws of physics. So in other words, it makes the impossibility of physics possible. And science of matter, motion, and energy is exotic matter. And matter with negative mass, no one can prove that it exists. And negative energy is needed to repel gravitational forces trying to bring the walls of the wormholes together. Okay, so we got the laws of physics now. In other words, you wouldn't be able to put enough negative energy, which is present in any particle with a negative value, into a wormhole, okay, to keep it from collapsing. This rule has not been tested yet.
Well, who has the means of testing it? We don't have Johnny Knoxville to test it.
No, we sure do not. Okay, we have another thing called This is why we're a little late because I did. Kobe brought up Greenwich time in the town of Greenwich, and I said, "What a great idea! I'm glad we added this so we can stay on a little longer." So Greenwich time here. Okay, so before we get into Greenwich time, thank you, Jonathan Harris. Thank you, Johnny Harris. That's Johnny Harris channel. Okay, the poles, like North Pole is 90 degrees north, and the South Pole is 90 degrees south. And 0 degrees on the map equals the corresponding line, which equals the center of the world, which is, wait for it, Britain. Okay, what do you know about Greenwich? Anything, even the town?
It's the way you see it is not how it's pronounced.
Oh, that's true. It's spelled Greenwich.
Yeah, you pronounce it Greenwich.
Yes, like the Thames looks like Thames. It's pronounced Thames.
Well, and then you got Leicestershire, which is spelled Leicestershire.
Right. Interesting how that happens. Okay, so the Earth is divided into lines. All right, some lines are curved and some lines are straight on a map. And these lines are latitude, which is horizontal, and longitude, which is vertical. And the longitude line has the 0 point. The
And-
lines have a number associated with them.
Didn't longitude also require accurate clocks to get accurately?
Yes, which we'll be getting into soon. And the longitude, if you go to the right, which is east, the numbers go up every 30 degrees. And that's like go from 0 to 180 degrees east. And to the left, the number go up the other way, 0 to 180 degrees west. You know, and it goes up every 30 degrees. You know, plus 30, plus 30, plus 30, east or west. And the 0 degrees, that's from which all east and west things are measured, from the 0 point, as they call it. So latitude, you go up, you know, so the lines like this is latitude, and then you keep going up this way. It begins from 0 to 180 degrees north, and then you go down, and you begin with 0 to 180 degrees south. The one thing I don't know about the latitude going up and down, does it go up and down every 30 degrees, or is it different?
Not
number?
sure.
I'm not sure either. I'm sure somebody watching can tell us. The video I watched didn't make that clear. All right, so the poles make for a natural top and bottom of the Earth. We're doing this in the perspective of people who actually believe the Earth is round. We could talk about flat Earth after this. All right, halfway between the poles is the equator. 0 point, and measure everything everything is measured from the equator, which is the 0 point. And the longitude is arbitrary. That means it's open to interpretation, subjective. The center of the world can be anywhere. So with the longitude, in the old days, everyone had their own center of the Earth. So the grids equal longitude plus latitude. That's why you have these little squares that equal the grids. It's important for navigation. Many years ago, the navigation's home base, which is their home country, was the 0 point. So Japan at one time had their own home. People in Japan made Japan their 0 point. People in New Zealand made 0 their green point, and so forth and so forth. People in Nigeria made it 0 their point. Imagine in Africa, there's many countries, so many 0 points back then too. In the 1800s, countries aligned and started aligning with each other and traded with each other, but they still had a lot of wars. And before that, there was even more war. And the only difference was during these wars in the 1800s, people wanted to try to find common ground. But before the 1800s, they did not. And so we had a big industry of map making started booming in the 1800s, and sea navigation. Private businesses started making maps, and they wanted good quality seafaring maps because boat travel was still very popular. And now we're going to trains. So do you like riding trains?
They're cool.
I think they're very cool too, especially in Japan, right?
Okay.
Yes, I enjoy it a lot. My favorite mode of transportation in Japan are the trains. Shinkansen. Okay, and trains needed time. Of course, the time is very important for trains because they have a schedule to keep. That was their lifeblood. So people used trains to travel across the country during the 1800s. And they ran on coal, and also they needed timetables, which are schedules. And every time had to, before daylight saving, before the zero daylight saving time, and before they had a international 0 point, every place had their own time, on the train. So one time, even the next town could have a different time from the previous town, or the following town. It could be like one town could be noon, another town would be 12:15, another town 12:30, another town 12:45, another town 1 p.m., and so on. And so President Chester Arthur, I'm not sure what number president he was in the U.S. in the late 1800s. He's the one that had time organized. So he invited 41 countries, mostly European countries. I didn't have time to write down every country, to come to Washington, D.C. And this is where they agree on where the 0 point should be, which makes it the official center of the world. Okay, and that measures time and navigation. So the majority of the countries voted on a center point, and they wanted to go through London, England. But they end up picking the outskirts of London, which is Greenwich. Did you know all this?
Yeah.
Oh, you knew all that. That's great. So what do you think about all this? Do you remember which countries participated?
No,
Okay.
because they're all backwaters.
Okay. So like Eastern Europe and all that.
And the Netherlands.
The Netherlands too. Be careful because people in these countries could be watching and listening. Okay, so
All right. Well.
Greenwich.
Okay, let's test that.
No.
If you're from Mozambique, your country sucks.
Okay, stop. Okay.
Do you even know where Mozambique is?
Africa. Okay, now Greenwich, home of the Royal Observatory, the British Empire. So prime meridian equals 0 point, which is east and west. And only Santo Domingo, which is now the Dominican Republic, said no at the time during the 1800s. And France eventually got on board, and they initially said no. And now we're going to find out why is Brenton the center point of the world? Why is it, man? And why is it, Kobe?
I don't know. Can you tell me?
I don't know. Do you have any idea?
Arbitrary?
Yes, that's a good way to sum it all up in one word. Because Britain had the largest, most powerful navy, and the most experience with maps and oceanfaring. So it's like majority rule.
Wasn't the Mercator projection made by Belgium though?
It might have been. That's a good point. Okay, so natural choice. That's why it's a natural choice for them to be the center of the world. Okay, so Greenwich, the time is set at noon, which is the Greenwich Mean Time, MEAN, and the 0 point is east and west. Okay, but thanks to more accurate measurements, it's no longer Greenwich is no longer on the Royal Observatory because for better tools for measuring, like I said before, of course, for measuring longitude and latitude. and it's affected by daylight saving time. So in Greenwich, you go west, and you go. It's if it starts at noon, you go west. It's 11 a.m., 10 a.m., and then 9 a.m. and so on. You go back from the Greenwich Mean Time. Now, if you go east, then you start at noon in the Greenwich, at the 0 point in Greenwich. There'll be 1 o'clock, 2 o'clock, 3 o'clock, and so on, and going forward from the Greenwich Mean Time. Okay. Oh, yeah, a little more. Yeah. Thanks. See your handsome face. Okay, so if you get 12 steps away from the Greenwich Mean Time, which west or east, it doesn't matter, you go to here it is, International Dateline. And that's where the new day begins. Fiji is near there. Okay, so on one side of the International Dateline, it could be, let's say 4 a.m. tomorrow, which is Thursday, April 27th. And you go on the other side, it'll be 4 a.m. Friday, April 28th, a full 24 hours later. So in other words, if you cross the International Dateline, you're in front of the Greenwich, Mean Time. Greenwich, Mean Time. And Fiji, the island of Fiji is near there. So that's so much on time. And I mean, I would love to get more information about time as well. It's just so much information, and I just couldn't get all of it before this wonderful, live stream. And okay, let's discuss flat Earth.
When are we gonna end the live stream?
We're gonna end it in like 10 to 15 minutes. So, flat Earth, because maybe some flat earthers are watching. So what is?
Where?
You never know.
Well,
okay.
Are they in the room right now?
Okay, let's put it this way. Okay, so flat Earth. Do you believe in flat Earth?
No.
Why don't you believe in flat Earth?
Well, why do I not believe in it?
Yes.
Well, that is a good question. Because I don't have a good way of explaining it.
Let's do the best you can. It's okay.
Well, I just feel like if the world was flat, then we would be able to see the sun and the moon at the same time.
That's an excellent point. You're right. Some people believe the Earth is really flat like a plate, and it's like a snow globe where it's covered by a dome, and there's no space. And the planets and the moon and the sun are just light, and the sun is only 3,000 miles away. It's lights in the sky. But no one has answered what is on the bottom of the flat Earth. It's like having a plate and not knowing what's on the other side of that plate.
But then why can't you just use a weather balloon
and
a camera?
That's true. And they say that supposedly there's only a South Pole. There's only a North Pole. There's no South Pole. I hope I did not get that mixed up. If I did, I apologize. Otherwise, one pole doesn't exist on flat Earth. In fact, the What If channel did a segment on that. They said that if Earth were flat, the trees would start growing sideways and the gravity wouldn't be even. It'd be strongest towards the center, weakest going out. And supposedly, some people believe in the flat Earth being water above and water below. So what are your thoughts about all that?
I don't see how this is relevant to time.
Okay. Well, that's a good point. All right, I guess we could make it relative to time is when did the Earth become flat? What amount of time? And how would time be affected if the Earth were flat?
Well, that's not what I would know.
That's true. Well, hopefully
that sounds like theoretical stuff.
Well, time is theoretical. Don't you believe it? Don't you believe it can be theoretical time?
Yeah, feel like with time you can probably make it more objective.
That's true. Well, time, if they said if we didn't see anything move, we wouldn't know that time exists.
Well, if time was subjective, then would that mean every day it has a different amount of hours? So we're saying this day has 24, this day has 22, and this day 21, and
Yes, they-
3/4.
Oh, actually, I saw a commercial when I was a child. This guy said that, the day does not have to be 24 hours.
Well, yeah, but it's still pretty consistent when it's 24 hours.
Yes, or with some people, I said some people may say we're just used to that. And also, I did see one. I didn't have time to take notes on it, but I just got to go by memory on one of what ifs. What if we could stop time, or what if time stopped? Similar subjects. Two separate videos, are very similar subjects. On one video, I forget which one. If time did stop, and we stopped with it, we wouldn't know that time stopped. In fact, everything would stop, even things that keep us alive, like breathing. And if time did stop, everything will kind of look fluorescent because of change in the molecules in the air. And of course, Twilight Zone did an episode about time stopping as well. And they say you'd be blind, you'd be deaf, you wouldn't notice anything. And then if someone was able to make you move again, then you wouldn't remember ever stopping. So what are your thoughts about the stoppage of time like that, like being frozen?
It sounds very theoretical.
Well, thank goodness. I wouldn't want someone having that much power over me. I wouldn't want that much power over anyone either. That Twilight Zone episode, his watch broke and there was no one around to fix it because everyone's frozen forever. Pretty scary to me. That's the way I see it. And if you could go back in time, how far back would you want to go?
To be 1980s.
Oh, that'd be pretty cool to see what things were like in the 80s with your own eyes, right?
Oh, maybe mid 70s, and then
Yeah.
progress on to the 80s.
Yeah, that's true. Of course, let's not forget the butterfly effect either. If you step on something, it can mess up the future. Oh, and don't forget parallel universes. I saw videos on that too. Thanks to What If. It's like there's many universes, and you're in all these universes. And every time you have a new thought, you create a new universe, and you have a different life on every one of those universes. Imagine that. I know. Oh, and what would you do if you met a time traveler? We'll start from the simple and say from the future.
I'll ask him what country he comes from.
Okay. Japan.
Then I go to, well, then I'll make my eyes really wide and say, "Irashaimase."
Okay. Explain to the audience what that means in English.
Well, using my one man worth of Japanese, I think that means hello.
Oh, okay. One way to say hello, of course, Ohio or Konnichiwa. Yes, very good. Oh, what now? I have to answer. What would I do if I met a time traveler from the future? I'm more interested in the future than I am in the past. So to me, that would be very fascinating. I would have all kinds of wonderful questions for that person.
But what if he doesn't speak a language you don't speak?
Oh my goodness. Well, we have to communicate using charades. But hopefully,
That sounds really tedious.
Yeah, my biggest fear of the future is I have no more descendants. And of course, Kobe will make sure that doesn't happen. And I don't want to go to the past because my past wasn't fun for me. Well, that's the way I see it. So Um, and so I find, even if it's not true, time travel, there's nothing wrong about being fascinated by something that might not even exist or ever exist. So, well, hopefully they will discover wormholes. To me, that's quite interesting. Just because they discover wormholes doesn't mean we have to use them. Let someone else do the wormhole thing. So it's like tunnels. It's cool, like you, almost like a play equipment where you go all these different tunnels, and all these different adventures, in all these different directions. And to me, that's cool. What's cool to you about time?
Um, if time keeps going, I can play video games.
Oh, okay, yeah. Well, that's good. I'm glad you enjoyed, playing your video games. But that's for sure. So I'm also fascinated by the closer you get the speed of light, um, the slower time goes, and the slower you age. I'm 59 years old. To me, that's good news. And they say if you come, like people in the space station are milliseconds more in the future than us. So they come back milliseconds younger when they come back from the space station.
Until the space station runs out of funding.
Yeah, that too. Well, hopefully it won't.
I think the ISS is almost out of money.
Oh. Well, hopefully that can be resolved, but we can't resolve it here. But zero gravity, I've always wondered what it'd be like to float in that. That must be real. Still zero gravity.
I thought we were talking about time.
Yes, we are talking about time. Well, I'll let you lead the conversation on time now.
I don't think there's very much more to discuss.
Oh, there is much more, but I didn't have time to take notes on everything I found out about, time. We could talk about time travel. There's always lots of subjects about that. Like you could build a traditional time machine, like you see in science fiction, or you could build that Tippler thing, like the long, really long tube, like going through a giant pipe, and it's just spinning and spinning and spinning. To me, that's pretty cool. And I like the shortcut to the universes because we only live, for so long. But we're not going to live 200 years. So you want to get to the universe in 5 years or less because you get, you know, cabin fever in that spaceship if you travel, far enough. Yeah, that's for sure. Is there any movies you liked about time travel?
No, because their plots tend to be messed up.
Oh, like Interstellar. I saw that movie recently. I found that a very fascinating movie. Where he had to find another planet because the Earth was going to explode, and then he would get his messages. Like it takes by the time he gets his messages, there always been many years already passed. His children are grown, but he's pretty much the same age because they're traveling near the speed of light. Oh, Matthew McConaughey. Matthew McConaughey stars in this one. But the one part that broke my heart about the movie was when one of his grandsons died. His son had to say, Jesse's dead. I had to rewind that like 10 times to realize he really said that. But I do recommend the movie Interstellar. It, it does give you an idea what time travel, could be like. And there's other movies too, like Deja Vu, that has Denzel Washington, and that's about him catching a criminal, and he's getting clues from like the past and future, which he has to, look at so he can capture this criminal. I haven't seen that one. And of course, for another time travel recommendation, like some of the Family Guy episodes, if you have a sense of humor about time travel, and The Simpsons, and of course Twilight Zone. They do a good job with time travel stuff too. And like Rod Serling is said, the time they heed warnings of the past is in the past. So the way I interpret that is, if you try to stop yourself from doing something in the past, your future, your present self tries to warn your past self won't listen, because your past self might be frightened of you, not knowing it. That's them, like you're them. So I hope everyone's enjoying, discussion about time, and those who showed up for the live stream, thank you. And those who are just seeing this after it's recorded, thank you for coming. I realize there's no one good time, pun intended, for everybody when it comes to live streaming. Yeah, so I guess I noticed that the older I get, the faster time seems to pass for me. Does time pass slowly or quickly for you at age 21?
No idea.
Okay, I guess it pretty much stays the same for you, huh? But I guess the past, present, and future can be all in one place.
I think we have the live stream here.
Okay, well, we'll be ending in the next several minutes, our live stream.
Well, why not now?
Because I have more to say.
You're right on borrowed time here.
I know, but well, actually, you're probably making people laugh, so it's worth staying longer with your smart mouth. and they see you smile. Look at Kobe smile with his teeth. He hasn't done that since he was 14. 7 years, and now you're hiding your teeth. Why?
Well, because I just want to.
Oh, you do, huh?
Mm-hmm.
And in time, he'll get married and have children of his own.
Mm-hmm.
And his children will see this video with their future grandmother, me. And whereas my husband, he did not want to do the video. But that's okay. But I threw him some of his thoughts, even if I did not, project his thoughts correctly. At least I tried. So I guess if anyone has thoughts about flat Earth as well, that's welcome too, because when we talk about time, some people don't believe the Earth is round, and that's okay.
But I still don't know how this is relating to time.
I don't know, but people will throw in the shape of the Earth in with time, so I might as well do it first.
That makes no sense.
Time doesn't make sense sometimes.
No, but what? Okay, fine. All right. Well.
I guess we could play with words about time, like it could be on time, it could be behind time, it could be ahead of time. You could put time in a bottle, like the song by Jim Croce. So to me, that means you put it in a bottle so you can preserve it because you don't want to lose that moment. Beautiful song. Yeah, so I'm sure there's songs about time too, like Cher's If You Can Turn Back Time, because a lot of people are nostalgic about the past. I guess in my own way I am. That's why I take so many pictures so I can look back at them in videos on my Facebook. Just type my first and last name, you'll find my Facebook. Even if you don't, not my friend, you'll see everything. I'm pretty transparent. So here in Ecuador, we are near the equator, but we're not in Quito, the capital. That's the best place to be on the true equator. We're near Cuenca, which is a beautiful city. All right, Kobe.
Can we just end it now?
Oh, not yet. Okay, good. Now you think this is just worth keeping it going so you can see you smile. Come on. Look at this video years later, like when you're 42 years old. You see yourself at 21. Mm-hmm. Look at me, at, oh my God, when I'm 80. See me at 59. I'm sure I will still look amazing. I want to be a glamorous grandma. Yeah, thanks. Okay, come up more towards my left. Yeah, there we go. Everyone else is right. I can see your whole handsome face. Okay, we'll wrap it up now. Thank you everyone for coming, and please watch this. Okay,